There is a specific phrase in NOAA's current space weather forecast that does not appear in typical minor geomagnetic storm outlooks. The phrase is cannibal CME. It describes a specific physical scenario, one that requires multiple coronal mass ejections to depart the sun in rapid succession, with the later, faster ejection catching up to the earlier, slower one, while both are still in transit between the sun and Earth. And when it happens, the result is a combined plasma cloud that carries more magnetic energy, more particle flux, and more storm potential than either ejection would have produced on its own. NOAA's WSA-Enlil solar wind model, the computational simulation that the Space Weather Prediction Center uses to forecast the arrival timing and intensity of solar wind disturbances, is currently tracking that scenario for arrival at Earth between July 29th and July 30th, 2026. G2 moderate to G3 strong geomagnetic storm conditions are being forecast across a window that runs from today through July 31st. And behind the cannibal CME sequence, a large coronal hole that rotated onto the sun's central meridian on July 29th is preparing to launch a high-speed solar wind stream that will arrive at Earth approximately 3 to 4 days after it, extending the disturbed geomagnetic period into the first days of August. 3 separate solar disturbances, one overlapping with the next, the third arriving before the second has fully passed. A compound geomagnetic event that NOAA's issued formal watches for across a 3-day window. And the active region responsible for the flares that launched the first 2 components, active region AR4494, is still on the Earth-facing solar disk right now, still classified at Beta Delta, the highest magnetic complexity designation in NOAA's classification system, and still showing flux emergence that increases rather than decreases its flare potential as it moves across the disk. This is the most consequential solar week of summer 2026. And unlike the quiet diagnostic window this channel described last week, when the question was whether the sun was entering a decline towards solar minimum, this week the question has answered itself. The sun is still producing complex energetic activity, and right now it has aimed 3 separate disturbances at Earth in the same 7-day window. Let's go through each one, because each element of this week's solar story is important on its own, and because understanding how they compound each other is what makes the forecast for July 29th through August 1st more significant than any individual component would suggest. Start with AR4494, because this active region is the source of the flares that launched the CME sequence, and its current state on the solar disk is the reason NOAA's extended forecast beyond July 31st still cannot call for return to quiet conditions. Active region AR4494 retains its Beta Delta classification, the most energetically complex configuration, and continued to show flux emergence as of July 26th. AR4496, a newer region in the northeast quadrant, is growing and has many days of geo-effective potential ahead. Beta Delta. NOAA's magnetic complexity classification system for sunspot groups has 7 categories designated by letters that describe the magnetic polarity distribution of the sunspot group's umbrae. Alpha is a single polarity. Beta has both polarities. Gamma and delta designations describe configurations where opposite polarities are intermingled within a shared penumbra. Beta Delta, the classification AR4494 currently holds, describes a sunspot group with a complex magnetic polarity distribution and a configuration where opposite polarity umbra share penumbra within the same sunspot group. This is the magnetic configuration, most strongly associated with large solar flares, because the energy release in a flare comes from magnetic reconnection, the sudden snapping and rearrangement of field lines. And that process is most energetically triggered when opposite polarity field lines are pushed into close proximity by the dynamic evolution of a complex sunspot group. Sun News for July 27th, 2026. Active region AR4494, the source of the strongest flare of the past day. The M3.2 flare peaked at 1528 UTC on July 26th. M3.2, not M1, not M1.5. M3.2 at the upper end of the moderate flare class, approaching the threshold of the strong X-class range. An M3.2 flare is not a routine solar event. It is the kind of eruption that, depending on the associated CMEs speed and magnetic field orientation, can produce G1 to G2 geomagnetic storm conditions on its own. At this point in the week, it would not be wrong to say it was just the beginning, because AR4494 did not stop at the M3.2 on July 26th. The region continued to produce flare activity on July 27th and July 28th, and the additional eruptions from those days are the ones that launched the CMEs currently in transit toward Earth. NOAA has issued geomagnetic storm watches for July 29th through July 31 in response to a series of additional coronal mass ejections. Solar activity was elevated over the weekend, with solar flares and filament eruptions associated, with multiple new CMEs. Some carry Earth-directed components, with arrivals beginning as early as July the 29th due to an eruption early on July 27th itself. Additional CMEs, launched July 27 to 28, are expected to arrive around July 30th. And the WSA NLIL model projects, this could lead to G2 to G3 strong conditions. Multiple CMEs with Earth-directed components. Arrival sequenced across July 29th, July 30th, and July 31st. And the cannibal CME scenario emerging from the possibility that a later, faster ejection is catching up to an earlier, slower one, while both are still in transit across the 93 million miles between the Sun and Earth. The cannibal CME mechanism requires specific explanation because it is not a commonly used term in everyday coverage, and because its implications for storm intensity are significant. When the Sun fires a coronal mass ejection, the ejection travels through the solar wind at a speed determined by its initial launch velocity and how it interacts with the ambient solar wind in front of it. Faster CMEs are decelerated by the resistance of the ambient medium. Slower CMEs are accelerated by the push of the faster medium behind them. If a second, faster CME is launched from the same or nearby active region hours or a day after the first, it will initially be at a lower point in its trajectory but moving faster. Over the 24 to 72 hours of transit to Earth, the faster CME gains on the slower one. If the speed difference and launch timing are in the right range, the faster CME catches and merges with the slower one before either reaches Earth. When they merge, the leading edge of the combined structure carries the magnetic shock and compressed plasma of the merger, a structure that is physically larger, magnetically stronger, and carries more total particle energy than either ejection would have produced individually. The combined structure can also have a more complex magnetic field orientation than a single ejection, with the merged fields from two separate eruption events interacting in ways that are harder to model in advance. This is what NOAA's WSA NLIL simulation is currently tracking as the primary driver for the G2 to G3 storm potential on July 30th. G2 to G3 conditions, the level at which power grid operators at high latitudes face geomagnetically induced currents capable of saturating transformer cores. G3. This is the strong storm level, 3 steps below the catastrophic G5 that produced the Aurora visible over Florida and Mexico in May 2024, but 3 steps above G0 quiet. At G3 levels, geomagnetically induced currents in high latitude power transmission lines become operationally significant. Grid operators in Canada, Scandinavia, Scotland, and Alaska run their transmission systems with tolerance for some level of induced current fluctuation, but G3 conditions produce induced current levels that approach the limits of their protection system's design tolerance. Transformer saturation, when the magnetic core of a high-voltage transformer is driven into the nonlinear portion of its magnetization curve by induced DC-like currents from geomagnetic disturbances, increases transformer heating, and in severe cases can cause equipment damage. The G3 risk is not a certain outcome. It is what the WSA NLIL model projects as the upper range of the compound CME arrival scenario. The actual storm intensity depends on 2 variables that cannot be determined until the CME sequence arrives at DSCOVR, the satellite sitting at the L1 Lagrange point that provides the last-minute real-time measurement of the solar wind's actual magnetic field orientation. The first variable is the BAZ component, the north-south orientation of the magnetic field carried by the CMEs. If B is strongly southward, pointing opposite to Earth's own magnetic field, the coupling between the solar wind and Earth's magnetosphere is maximized, and the storm intensity reaches toward the upper range of the forecast. If BEZ is northward or fluctuating, the coupling is reduced, and the storm intensity stays in the lower range. The second variable is the actual arrival timing of the cannibal merger, whether it arrives as a single combined structure or whether the component ejections arrive sequentially with intervals between them. DSCOVR will answer the BZ question approximately 15 to 60 minutes before the CME arrival. That is the warning window. In that window, grid operators make their final switching decisions. Satellite operators execute their final attitude control adjustments. High-frequency radio operator S at high latitudes prepare for propagation disruption. And Aurora watchers check whether their local skies are clear, because Aurora is what most people want to know about. And G2 to G3 conditions produce Aurora at latitudes that make it visible to a significantly larger population than the G0 baseline. For tonight, observers in the northern United States, Canada, parts of northern Europe, and New Zealand may have opportunities to see Aurora. Under G2 conditions, Aurora could be visible as far south as New York and Washington, D.C. Under G3 conditions, the visibility extends further toward mid-latitudes, with sightings possible at latitudes typical of Paris, France, and southern Germany on the European side of the Atlantic, New York, Washington, D.C. Under G3 conditions, Paris, and southern Germany. These are the Aurora visibility benchmarks for the storm watches currently in effect. They are not guaranteed outcomes. Aurora visibility at any given location depends on local cloud cover, light pollution, how far south the KP index actually reaches during the storm's most intense phase, and the timing of the storm peak relative to local darkness. But they represent the credible range of Aurora visibility if the compound CME delivers the G2 to G3 storm intensity that NOAA's current modeling suggests is possible. The key indicator to watch in real time is the KP index, which updates every 3 hours from NOAA's global network of ground magnetometers. At KP5, you have a G1 store M, and Aurora is primarily in Canada and Scandinavia. At KP6, G2, the Aurora expands southward to include the northern tier of U.S. states. At KP7, G3, it expands further to include the mid-Atlantic states, and on the European side, to include France and southern Germany. Each jump in KP represents a real expansion of the Aurora's geographic footprint. And during a compound CME event like what is arriving this week, the KP can move from 5 to 7 within a few hours as the main phase of the storm develops. Now AR 4496. Because while the attention this week is appropriately on the CME sequence from AR 4494 that is currently in transit, the active region that is growing in the Sun's northeast quadrant deserves its own analysis. AR 4496, a newer region in the northeast quadrant, is growing and has many days of geoeffective potential ahead. New active regions emerging from the Sun's interior are the continuation of the solar cycle's activity. They develop from below the photosphere as magnetic flux tubes rise from the convection zone, emerge at the surface as new sunspot groups, and can spend up to 2 weeks crossing the Earth-facing disk, before rotating onto the far side. A region that is currently in the northeast quadrant of the disk, at the leading edge of the Earth-facing hemisphere, just rotated into view, has many days of geoeffective potential, because it will spend the next 7 to 10 days crossing the disk and will be in the most geoeffectively positioned zone, the central portion of the disk, for approximately half of that transit. If A4496 develops the magnetic complexity during that transit that AR4494 has already demonstrated, the period from approximately August 1st through August 5th becomes a secondary elevated flare risk window that extends the current elevated activity period beyond the immediate July 29th through July 31st CME arrival window. The Sun, in late July and early August 2026, is not showing a system in decline. It is showing a system with multiple complex active regions actively producing flares and CMEs simultaneously, and with new regions emerging from the interior to replace those completing their transit. This event arrives during a gradual decline from the peak of solar cycle 25, which began in December 2019. NOAA and NASA announced on October 15, 2024, that the Sun had reached solar maximum. EarthSky's solar dispatch for July 26 places the 365-day smooth sunspot number peak at October 11 to 12, 2024, with a strong decrease in activity visible by February 2026. Despite the overall decline, the Earth-facing solar disk currently hosts multiple sunspot regions with significant magnetic complexity. This is the context that changes what this week's events mean for the rest of the year. Solar cycle 25 officially peaked in October 2024. The 365-day smoothed sunspot number, the standard metric for determining solar cycle phase, showed a strong decrease by February 2026. By strict definition of the solar cycle's average behavior, we should be in a period of declining activity. The machine gun sun of early July 2026, the 3 CME sequence of late July, and now the cannibal CME plus A. AR4496 growth story of this week are all occurring in a solar cycle whose average has already passed its maximum. This is not unusual. The history of solar cycles is full of examples where individual active regions or short burst periods of intense activity occur months after the smooth maximum has been established. The mate. 2024 G5 storm, the most intense in over 2 decades, occurred roughly 6 months before the official October 2024 solar maximum. Intense events do not track the smooth cycle precisely. What the cycle position does tell you is the probability distribution of future events. As the cycle declines, the average frequency of X-class flares and major geomagnetic storms decreases. But in any given week, the presence of a beta-delta active region on the disk, regardless of where the cycle is, maintains the possibility of significant flares. AR4494's beta-delta classification is not a legacy of the cycle's peak in October 2024. It is a current, active, real-time classification based on what the NOAA solar region analysts are seeing in the magnetogram data from NASA's SDO right now. A beta-delta active region in a post-maximum declining solar cycle is rarer than at maximum, but its flare potential is not diminished by the cycle's phase. The magnetic complexity of an individual sunspot group is governed by local processes: flux emergence from below, differential rotation across the group, the interaction of the leading and following polarities as the group evolves. The solar cycle phase affects how frequently new complex regions emerge. It does not reduce the energy release potential of a complex region that has already emerged. Sun news for July 29, 2026. The Sun shows a large coronal hole now sitting over the Sun's central meridian. Coronal hole is a region in the Sun's atmosphere where the magnetic field opens out into space, letting fast solar wind escape. It appears dark because the escaping plasma leaves the region depleted. The coronal hole at central meridian is the third element of this week's solar story, and the one that extends the elevated geomagnetic activity beyond the July 29th through July 31st CME arrival window. A coronal hole positioned at the Sun's central meridian, the line that divides the Sun's Earth-facing disk into eastern and western halves, is in the configuration most likely to produce a high-speed solar wind stream that arrives directly at Earth. The Earth-Sun line passes through the central meridian, so a coronal hole at that longitude is directly aimed at Earth. The high-speed stream flowing from it will take approximately 3 to 4 days to travel from the Sun's surface to Earth's magnetosphere. With the coronal hole at central meridian on July 29th, the arithmetic puts its high-speed stream arriving at Earth approximately August 1st through August 2nd. Just as the effects of the CME sequence from July 29th through July 31st are potentially still winding down. The high-speed stream from a central meridian coronal hole typically produces G1 to G2 geomagnetic activity on its own, arriving while Earth's magnetosphere is already disturbed from the cannibal CME sequence. It extends the elevated geomagnetic period, rather than allowing a clean recovery. The specific impact of a coronal hole high-speed stream on a magnetosphere, still. Processing the effects of a CME arrival is a compound effect that space weather forecasters model carefully. The high-speed stream's magnetic field, compressed against the leading edge of the slower ambient solar wind in front of it, produces a stream interaction region, a zone of enhanced magnetic field and plasma density that can add to the geomagnetic activity driven by the initial CME impact. If the CME sequence delivers G3 conditions on July 30th, and the magnetosphere is still in recovery when the high-speed stream arrives August 1st, the stream could prevent the full recovery that would otherwise bring the KP back to baseline, producing a prolonged period of elevated geomagnetic disturbance. This three-component sequence, cannibal CME, growing complex active region, central meridian coronal hole, is the architecture of why everything depends on this week for the solar activity picture through early August. The honest characterization of the forecast as of this morning has two components. First, what is certain? NOAA has issued formal geomagnetic storm watches for July 29th through July 31st. Those watches are based on observed CME eruptions from the weekend, tracked in coronagraph imagery and confirmed in Enlil solar wind model. Output: the watches will either verify when the CMEs arrive at Dieskova or they will not, but the underlying physical events, the eruptions, the CMEs in transit, are confirmed. Second, what is uncertain? The exact storm intensity depends on the BZ component that Dieskova will measure approximately 15 to 60 minutes before Earth arrival. A strongly southward BZ delivers G3. A northward or fluctuating BZ delivers G1 or G2. The difference between those outcomes for Aurora visibility and infrastructure impact is significant. What to watch in the next 48 hours is specific. The Dieskova real-time solar wind data stream, publicly available at the NOAA SWPC website, is the first indicator of the CME arrival's actual character. When Dieskova shows a sudden increase in solar wind speed and a sharp jump in the IMF strength, the classic signatures of a CME shock front passing through the L1 point, the storm is arriving. The Bayes reading in the minutes immediately after the shock is the most critical number in the immediate forecast. Sustained southward BZ above 10 nanoteslas for more than an hour drives KP into G2 territory. Above 15 nanotelsla, sustained for several hours, drives KP into G3. For anyone in a position to see the aurora, the southern limit of aurora visibility during the storm's most intense phase, which typically occurs 12 to 24 hours after the CME arrival as the main phase of the geomagnetic storm, develops depends on how high the KP reaches. During the May 2024 G5 storm, aurora was seen as far south as Florida, Texas, and Spain. During G3 conditions, the expected southern limit is approximately 50 degrees geomagnetic latitude in both the northern and southern hemispheres. That latitude cuts through the northern United States, Canada, Central Europe, and on the southern hemisphere side through New Zealand and southern South America. Aurora is not the infrastructure story. It is the visible expression of the same magnetic energy deposition that simultaneously drives geomagnetically induced currents and power. Grids, increases satellite drag in low Earth orbit, degrades GPS positioning accuracy, and disrupts high-frequency radio propagation at high latitudes. In a G3 storm, all of those effects are operating simultaneously. The aurora is what makes the storm beautiful. The other effects are what make it something that power grid operators in Quebec, the satellite operators at SpaceX, and the radio operators at Reykjavik Air Traffic Control are actively managing. There's a phrase in the Earth Sky Forecast summary for this week that captures the overall situation with appropriate precision. Despite the overall decline, the Earth basin, G-Solar Disk currently hosts multiple sunspot regions with significant magnetic complexity. Despite the overall decline, the solar cycle is past its maximum. The long-term trend is toward quieter conditions. Despite that, today's solar disk has AR4494 at beta delta, AR4496 growing in the northeast quadrant, a cannibal CME in transit with G2-G3 storm. Watch is active, and a central meridian coronal hole whose high-speed stream will arrive just as the CME effects are clearing. This is not the sun at its maximum. It is the sun in a declining cycle that is not done producing significant events. And this week, with the compound CME sequence arriving, the beta delta active region still present, the new growing region to its east, and the coronal hole high-speed stream following 3 days behind, is the week that tells us how much energy the declining cycle still has to deliver before it returns to quiet. Everything depends on what the BZ shows when DSCOVR reads the cannibal CMEs. Magnetic field in the first minutes of arrival. That measurement, one number in one direction measured 15 minutes before the storm reaches your magnetosphere, is what determines whether tonight's aurora reaches New York or stops at the Canadian border, whether July 29th through 31st becomes one of the most active 3-day periods of the summer or merely an elevated but manageable G1, G2 sequence, whether the August follow-on from AR4496 builds on an already disturbed magnetosphere or arrives into quiet conditions, one number, arriving at DSCOVR in the next few hours. Everything depends on which way it points. Subscribe right now and turn on the notification bell. NOAA SWPC updates its space weather forecast every 3 hours. DSCOVR, real-time data is public. The KP index refreshes continuously. When the cannibal CME arrives at L1 and the BZ confirms which storm scenario is verifying, this channel will have the update immediately.